Hello, this video is going to go through how to calculate the volume of a prism. We're going to start with the basics and just how you do the volume, and then we're going to move on to some problem solving type questions where you might have to find a missing length, or when you might have kind of compound shapes and have to find the area of those. So I'm going to just jump straight into it and get started so it's not too long. Here we have the formula for finding the volume of a prism. Okay, that should say volume of a prism really. We look at the cross section always. So we always look at the cross section, we find its area, and then we multiply by the length. So the cross section is, if you imagine a prism, it has a consistent shape all the way through. So if you were to slice it up, you could have shapes, you could have slices that are all exactly the same shape. And the cross section is what shape that would be. So in this example, we have a triangular prism. So your cross section is this triangle at the front. If you were to slice the shape kind of through the middle like that, each of those slices would be a triangle, the same size as this one at the front, okay? To find the volume then, we take that triangle, find its area, and then multiply by the length. And by length, I mean this dimension here. So that's how far, so from the cross section, how far it's been kind of extended back. Okay, so in this example, it's 20. So we are going to start by finding the area of the triangle. We find area of a triangle by doing 1/2 times base times height. So our base is 6, our height is 4. 6 looks a lot like a B, doesn't it? 6 times 4 is 24, times it by 1/2 or divide it by 2 is 12 centimetres squared for now, because remember this is the area just of the triangle. We haven't found the volume yet. To find the volume, we need to take that area and multiply it by the length, which is 20. So that gives us 240 centimetres cubed is our answer, is our volume. And it's as simple as that, okay? So you should know how to find all of the basic areas for the cross-sectional areas. And then as long as you can do that and then multiply it by the length, you will get the volume, okay? Right, let's keep going. Here we have a more complex shape, but it's still a prism, just the cross section is a compound shape rather than kind of a basic polygon. So the cross section is this T shape. The length is how far back it's going, so it's 5. That 5 would be the same here, be the same there, and here, and here. Those lengths all going in the same direction would all be 5. The only way we're going to be able to do that is if we take the cross section and we split it into 2. So we have 2 rectangles. We know how to find the area of a rectangle. So I'm going to find the area of the T first. Okay, so if we just look at the T, I'm going to just draw it out separately so we can look at it in isolation. So we are splitting it across here. The top rectangle has dimensions 3 by 16. The long rectangle has dimensions 13 by 4. We're quite lucky here that we don't have to work any extra lengths out. Quite often you would have to. So the area of the T, to get the area of the first rectangle, we would do 16 times 3, because it's just a rectangle, so we just do length times width. 16 times 3, oh goodness, I don't need my calculator, it's 48. Again, this is still area, so it's 48 centimetres squared. The area of the second triangle, rectangle, is 13 times by 4, which is 52. And again, still talking about area, so it's centimetres squared. So the total area of the whole T shape is 48 add 52 is 100. 100. That's nice and easy to work with. So the area of the T shape is 100 centimetres squared. Now we need to work out the volume. So to do the volume, we multiply the cross-sectional area, which is 100, by the length, which is 5. So the total volume is 500 centimetres squared. And that's it done. Like I say, still really, really straightforward, especially when we're just working with rectangles, really. Okay, let's keep going. The next one is not technically a prism. A prism, by definition, is a 3D shape that has straight edges. Okay, it doesn't have any curves in it, whereas a cylinder quite clearly has a curved face. But for the purpose of we are going to treat it as a prism, because we can still work out the volume in the same way. Okay, so for the volume of this, we need to work out the area of the circle face. So the area of the circle is pi r squared. We've been given the radius is 4, so we're going to do pi times by 4 squared, which is pi times 4 squared is 50.27 to 2 decimal places. And again, that's centimetres squared because that is just the area. For the volume, we are going to multiply that area by the height of the cylinder, which is 10. So that gives us 502.7 centimetres cubed as your answer. Okay, so again, not strictly a prism, but the formula still works, even though it doesn't have straight edges and we can't classify it as a prism. We can still calculate the volume of it in the same way. The formula still works. Okay, now we're getting into the more difficult problem solving questions. So here we have a triangular prism. The triangle has base of 6 and height of 8, and we need to find the length. So to find we've been told the volume is 120 as well. To find the volume, oh, that's still the highlighter. To find the volume, we would usually do the cross-section area multiplied by x, multiplied by length. Okay? In this example, we don't know what x is, what length is, so we're just calling it x. But we can work out what the cross-section area is. So if we find the area of the triangle, so we're doing a half times base times height, so 6 times 8. 6 times 8 is 48, times it by half is 24 centimetres squared. That means to find the volume, we are doing 24 multiplied by whatever x is, and that gives us the answer 120. We need to reverse that to find what x is, so I'm going to divide by 24, which gives us the length x. 120 divided by 24 is 5. So the length that is missing is 5 centimetres. I should probably put centimetres there, shouldn't I? Okay, so x is 5 centimetres. And that's it. Again, it's just working that formula backwards. As long as you can find the cross-section area, you can then divide it by the volume, or divide the volume by the cross-section area, and that will tell you the length. And then the very last question is a trapezium prism. Okay, the face at the front is a trapezium, the cross-section is a trapezium, and you're being asked to find the volume. But I'm going to show you it in 2 different ways. So the first way is using the area of a trapezium, okay, which you should know is a half a plus b times by h. Okay, lots of different ways you could write that. You could write it as a plus h times h all over 2. Lots of different ways, but I'm going to write it like this. Just really quickly, just to make it nice and clear, if that is my trapezium, this is 12, this is 15, and this one here is 9. we have to add the parallel sides. So your parallel sides are 12 and 9. So they are our A and B. And then we're multiplying it by the height, which is 15 in this example. So 12 plus 9 is 21. Times it by 15 is 315. And then divide by 2 times by half is 157.5. That's centimetres squared, because it's an area. Then to find the volume, we multiply that by the length, which is 6. So 157.5 multiplied by 6 gives you a volume of 945 centimetres squared. Cubed, sorry, because it's volume. Cubed for volume. And that's it. Okay, as long as you know this formula, you can answer this question really straightforward by just finding the area and then multiplying it by the length. However, if you can't remember the formula, there is another way you could do this. So yeah, I'm gonna split it up like this into a triangular prism. Okay, so I have this shape at the top, like that, and a cuboid at the bottom. And I'm going to find the volumes of both and then add them up. So for the triangular prism, I have a base of 15. I'm going to move this one down so I have more space. That's better. I have a base of 15. This is 6. The length is 6. I need the height of it. Now, based on the diagram, the whole height of the shape is 12. This part here is the same as that, is 9. So that means if we do 12 take away 9, that means this bit left has to be 3 centimetres. So we find the area and then multiply it by the length. So area is half times 15 times 3. 15 times 3 is 45, divided by 2 is 22.5 centimetres squared. And then to find the volume, we're going to multiply that by 6. Really easy. 22.5 times 6 is 135 centimetres cubed for volume. The cuboid, the dimensions are all there already. The base is 15, this height is 9. And the length is 6. And cuboid volume is really easy. You could do it by working out the volume, the area of the rectangle at the front and then timesing it by 6. But you're going to do the same thing in the end. You're going to multiply 15 by 9 and then that answer you're going to multiply by 6. So you can make it a little bit easier and do it all in one step, which gives you a volume of 15 times 9 times 6 is 810 centimetres cubed. So then to find the total volume, you add those two things together. So the volume of the triangular prism and the cuboid together, 135 add 810 is 945 centimetres cubed in total. And that is your final answer. So we still get the same answer as before, 945, but a little bit more of a long way and winded way of doing it. But if you can't remember the formula for the area of a trapezium, this way might be a little bit easier for you. You don't have to remember that formula. Most of you should have no problems remembering area of a triangle and area of a rectangle. Whereas a trapezium is a little bit more complex and people sometimes forget it. So there's two ways you could have answered that question. Okay? And that's the last one. That is the last thing I wanted to go through today. So you've seen lots of different types of volume of volume of a prism questions there. You've seen triangular prisms, you've seen trapezium prisms, you've seen compound shapes made up of different cuboids. You've seen a cylinder, which is not technically a prism, but we can still use the formula. Lots of different things going on there. which should hopefully prepare you to answer pretty much any type of question surrounding a volume. Okay, hope it helped. Thanks for listening to it.